Hi, Wilson.
Hi.
All right, so on this example, so you'll notice probably that for this example, we're still solving quadratic equations. And remember, if we want to solve a quadratic equation using the zero product property, we want to have the equation equal to 0. It has to be equal to 0 in order to use that. So if you see an equation like this example, the first thing they did was they moved the 6x and the plus 2, and they rewrote that equation to make it equal to 0. Does that make sense?
Yeah.
Yeah. All right, let me get the correct pen here. All right, so they subtracted 6x, so x minus 6x gave them the minus 5x, and then subtract 2, and they then were left with this equation. And then now that you've got it equal to 0, you want to think, all right, could I factor this and then use the zero product property? Yeah, you can factor it. So now that you've got this and this, that times that equal to 0, you then can say, all right, I know then that means 3x plus 1 has to be equal to 0, or x minus 2 has to be equal to 0. And then when you solve it, you get negative 3 or 2. So the your turn was pretty much like that. So on number 4, you look at the equation, it's got x squared, so that tells us it's quadratic. That makes me think, all right, I want to make it equal to 0 and try to solve it by factoring. So you subtract 2x from both sides and subtract 3 from both sides. That way it'll make this side equal to 0. So when you take 3x minus 2x, that leaves you with, nothing happened to 14x squared, but 3x minus the 2x leaves you with plus x. And then you don't have any constant over here, so when you subtract the 3 on that side, it becomes minus 3. And now you have it all equal to 0. Does that make sense, Desiree?
Yeah.
Good. All right, so now I'm thinking, all right, I want to factor this. So before we start trying to think about binomials, what's the first thing we want to look at, Fatima?
GCR.
Yeah. Is there a GCF of these three terms, 14x squared, x, and minus 3?
1.
Yeah, 1, and 1's not going to change anything, right?
Nope.
So yeah, there's no GCF. They don't all have x. 14, 1, and 3 don't have a common factor other than 1. So you can't take out a GCF. So at this point, we need to be thinking, all right, how can I factor this into the product of two binomials? Well, you look at the minus here. So what does that tell you? It's going to have to be a plus
And a negative.
and a minus. And what are the only factors of 3? Of negative 3?
1 and 3.
Yeah.
1 and yeah.
So you know it's either going to be plus 3 minus 1, or it could be plus 1 minus 3. So we're going to have to try some different things. Now, think about factors of 14x squared.
2 and 7.
2x and 7x, or 14x and x. So let's try 2x and 7x. All right. So now I need to take the product of these. 3 times 7x is 21x. 2 times negative 1 is negative 2. So what's 21 plus negative 2? 19. But what's it supposed to be equal to?
X.
It's supposed to be equal to 1x, yeah. So that doesn't work. That's okay. So I could switch it. I could switch the 2x and the 7x. To save some time, does anybody want to tell us what works?
2x plus 1, 7x minus 3.
So if we would have made this 2x plus 1, so we could have switched the 3 and the 1. Now what do we notice? When you multiply the 1 times 7x, that gives you 7x. And then when you multiply the 2x times the negative 3, that gives you negative 6x. So the 7x and the negative 6x go together to give you the plus 1x. So yeah, so you figured out then that your two binomials would be this. So since this times this is equal to 0, we know then that either 2x plus 1 is equal to 0, or 7x minus 3 is equal to 0. and then just solve the two equations. Subtract 1 from both sides and you get 2x equals negative 1, and then divide by 2. X equals negative 1/2. And then on the other side, add 3 to both sides and you get 7x equals 3, and then divide by 7 and you get x equals 3 over 7. So there, are your two solutions for that quadratic equation. Right? That's what you got, Fatima?
Yeah.
Good. Makes sense, Desiree?
Yeah, makes sense.
Good. Krause, you with us?
Yep, I'm still here.
All right. Wilson, you agree with that? Okay. Questions, anybody? All right, so let's look at the next one. So again, we want to make it equal to 0. It's quadratic. I see x squared, so I want to try to make that equal to 0. So subtract 8x from both sides. Do we have any x's over here?
No.
No, so that's like 0x. So when you subtract 8x, you're going to be left with 8x squared. You're going to be left with minus 8x when you subtract 8x from that side. But when you take this 3 and subtract 9, what do you get? Minus 6? Yeah. So you just subtracted 8x and 9 from both sides. Now you've got the equation equal to 0. So now we can think about factoring and use the zero product property. Before we first start going to binomials, what do we need to look at?
GCF.
And do we have one, Desiree?
Yeah.
What?
2.
Good. You notice 8, 8, and 6 obviously have a factor of 2, so you can factor 2 out of this before we try to make binomials. So when you factor 2 out, do you agree with 4x squared?
Yeah.
And then do you agree with minus 4x?
Mm-hmm.
And then minus 3?
Yeah.
Yeah. So now we've got a more simple trinomial, and now we need to be thinking about how can we factor this. So I'm thinking, all right, I want to factor this and then use the zero product property. So my options, again, I see minus 3, so I know one's going to be plus and minus, right? And the only factors of 3 are 3 and 1, so I could start by trying plus 3 minus 1, and then think about the factors of 4.
2 and 2.
2 and 2, so you could try 2x and 2x.
Yeah.
And what happens there? 2x times 3 is
6x.
6x. 2x times negative 1 is,
Negative 2x.
so what is 6 plus negative 2?
4x.
It's positive 4, right? But we need negative 4. So
You would flip the...
yeah, so let's just try switching them and then see if that'll turn it into negative 4. So I'm just going to switch the 1 and the 3, and now do you see 3x times negative 2x times negative 3 gives you the negative 6x, and then this gives you plus 2x. So now that's going to give you the minus 4x that you need. Good. So to use the zero product property, in order for all of this to be equal to 0, that 2 doesn't matter out there. If this is equal to 0 or if this is equal to 0, just like before, that's going to make all of this equal to 0, which is what we want. So now you just create your two equations. 2x plus 1 equals 0, or 2x minus 3 equals 0. Subtract 1 from both sides, and you get 2x equals negative 1. And then divide by 2, you get x equals negative 1/2. Or on the other side, add 3 to both sides, we get 2x equals 3. And then divide by 2, you get x equals 3 over 2. So those are our two possible solutions. Questions?
No.
All right. Krause, have you learned anything?
Yes.
All right. All right, so the next part, it just reminded you of these special situations. Remember, if you've got a difference of two squares, you can factor them into a plus b times a minus b. Remember, like if you had x squared minus 25, how could we factor that into two binomials, Desiree?
Wouldn't you square each one?
It's just going to be the square root of this,
Mm-hmm.
which is,
X.
yeah. So
And
you know
then
they're both going to,
negative 5.
yeah. Are they both going to be minus 5?
Yeah, because 5 times 5 is 25. No, one's gonna be negative, one's gonna be positive.
Yep. Anytime you have a difference of squares, you can factor that into two binomials where one's going to be plus and one's going to be minus. So because then what happens when you multiply these two and these two, the plus 5x and the minus 5x cancel out to make 0. That's why there's not that middle term in these difference of squares. All right, and then perfect square trinomial reminded you that anytime you're squaring a binomial, that the middle terms always double the square root of the a and the b. You don't have to remember all that to answer these, but it might come in helpful. So on this example here, notice they just factored out 4, just like you guys were doing before. And then they factored that into x minus 3, x minus 3. It's a perfect square trinomial. On this one, they were able to first factor out 9, and now you've got this difference of squares, so you know that's going to be x minus 2 and x plus 2. And then on this one, they factored out the 3, and it turned into that, and that turned into, again, a perfect square trinomial, so that's going to be x plus 1 times x plus 1. So all you have to do is make x plus 1 equal to 0, solve it, you get x minus 1. X is equal to negative 1. All right, so looking through this, 5x squared minus 20, what do I want to notice first? I want to think GCF.
Oh yeah, it's 4. No, 5.
Yeah, you can factor out 5 from both, and that's going to leave you with x squared minus 4. So now we have just two numbers. We don't have a trinomial, we just have a binomial. So I'm looking at that and thinking, is this a difference of squares? Can we factor x squared minus 4?
Yeah.
Can you take
Yeah.
the square root of x squared? Yeah. Can you take the square root of 4? Yeah, so
Yeah.
that's a difference of squares, so we can break that up into two binomials by taking the square root of x squared, which is x, take the square root of 4, which is 2, and remember, one's going to be plus and one's going to be minus.
Yeah.
So we now have it factored. Since it's all equal to 0, we can use the zero product property, so we know then that x minus 2 is equal to 0, or x plus 2 is equal to 0. So then when you solve each of these, on this one you get x equals 2, and then when you solve this one, you get x equals negative 2.
Mm-hmm.
So there are your solutions.
Oh, snap. What if you put, oh, never mind. Never mind.
All right? Okay.
Like, what if you were earlier in it when you just had it like 5 multiplied by x equals 2 minus 4 equals 0? What if you just saw that you can just make it? Yeah, like, no, I really. And you just made x2 right then and there, and then would that technically already? I guess I'm not making any sense. I'm getting tired.
All right. Could you I mean, just remember the square root method. Could you use the square root method on this? Now that you've factored it like this, you've got 5 times x squared minus 4 equals 0. How could you eliminate that 5?
Divide by 5.
Yeah, couldn't you divide both sides by 5?
Yeah.
And that's going to cancel out the 5, and that would leave you with x squared minus 4 equals 0 divided by 5 is 0. And then couldn't you add 4 to both sides?
Yeah.
And then you get x squared equals 4. So then take the square root. So that means x could be the positive or negative square root of 4,
Yeah.
which is going to
Yeah.
give you positive 2 or negative 2, exactly like you did here. Those are pretty much the only two options that I see that that you could do it. But Yeah, sometimes you can still use the square root method to solve these. But on all of these, we can practice some factoring. So on 7, hopefully you see a common factor of 2 that you can take out. So if you factor out 2, you're left with x squared. Finish it, Desiree.
X squared minus 4x plus 4.
Yeah. And all that's equal to 0. So now we want to think, all right, let's now think about how we can factor this. In order to get a plus and a sum of negative, what do we know about the two terms, the two binomials?
Wouldn't it be, it would be 2, the GCF, right?
Well, the 2 is going to be here, and now I'm thinking about the two binomials for this trinomial here. Since you've got a plus 4, what are the only two ways to get a plus 4? Either 2 times 2, or negative 2 times negative 2, or 4 times 1, or negative 4 times negative 1. What does the middle term tell you that it has to be?
A positive and a negative.
If you multiply a positive and a negative, is that going to give you the plus 4?
Oh no, give me negative.
So the only way to get a positive is either positive times positive or negative times negative. But if our sum has to be negative, doesn't it have to be minus and minus? And then if you do 2 and 2, you'll see that this is a perfect square trinomial. So negative 2x plus the other negative 2x is going to give us the negative 4x here. So since these two are the same, we only have to solve for one of them. So we can say x minus 2, one of those has to be 0, so when you solve it, you get x equals only positive 2. Agree, Desiree?
Yeah,
Alright.
because I put positive and a negative. Like I didn't put both negatives.
Alright, but do you see how that would not work? Okay, alright. Fatima, you're 100% correct so far?
Yeah.
Good for you. Alright, so let's look at 14. So Desiree, you already started looking at that one, and you correctly said if we want to first solve this for 0, you could subtract 9x from both sides, right? So 5x squared is going to stay 5x squared. So do you agree that that's going to give us negative 19x? And then when you subtract 4, there's nothing over here to subtract it from, so 0 minus 4 is negative 4. Alright, so now we've got our trinomial. Any GCF? No. So I now want to think, alright, how can I factor it into two binomials? Well, you can only get 5x squared by 5x and x. And since this is a pretty large number, what are you thinking about for your, what about using for your factors of negative 4, Fatima?
4. Plus 1 minus 4.
Yeah, if you do 1 and 4, where can that 4 go? That 4 probably needs to go with the 5, right, to make 20? The more you practice these, the more you're going to see things like this. Well, what's the sign here? It's negative 19. So that means it looks like I probably need that 20 to be negative 20. So if I do 5x times negative 4, that gives me negative 20. That means in order to make that negative 4, this one has to be plus, and the other factor of 4 would be 1. So if you put it together now, the plus 1 and the negative 20 go together to give you the negative 19 that you need. You didn't have to see that automatically. You could have tried plus 4, negative 1, plus 1, minus 4. You could have tried plus 2, minus 2. You would eventually have found that this is the one that works. Well, now, you just make each one equal to 0. 5x plus 1 equals 0, or x minus 4 equals 0. Subtract 1 from both sides, you get 5x is negative 1, divide by 5, x equals negative 1/5. And then on the other one, just add 4 to both sides, and we get x equals 4. So there are our two solutions for 14. Wilson, does that make sense?
Yes.
All right. Wilson, you're so polite to keeping it on mute when you're not talking. You guys are all being quiet today. It's nice and calm. Akraz left us.
Yeah.
I'm shocked.
But he doesn't even understand this.
I know he didn't look at Friday's assignment, so hopefully he's looking at the video from Friday and trying to catch up.
Fun fact, Akros is actually in the group chat with me, Akros and Michael. Akros puts in, hey, guys, join the meeting.
And then he left.
He tried to get you to join, and now he bails. Do you think he's working on his math right now, Wilson?
I don't know what he does.
I doubt it.
All right. Well, hopefully he'll. At least he tried to join the meeting today. All right. So 15. Again, we're thinking, all right, let's make this equal to 0, and then we can factor to use a zero product property. So when you subtract 2x from both sides, do you agree with negative 10x?
Yeah.
And then when we add 4 to both sides, there's no other constant to add over here, so that's just going to leave us with plus 4 on that side. And now we have it equal to 0. You're thinking GCF. What's the GCF?
2.
Just a 2. Yep, so if you factor out 2, that gives you 3x squared minus 5x plus 2 equals 0. Now we've got a trinomial, so I'm thinking, all right, I want to try to factor this into two binomials. Luckily, there's only one way to get 3x squared, so I know it's got to be 3x and x. And this looks like it could be pretty easy. The only way to get plus 2 with a negative in the middle is negative 2 times negative 1, right?
Mm-hmm.
So it's just a matter of either putting the minus 2 here or putting the minus 2 here.
It would be here.
Here. Yeah, because now when we multiply the 3x times the 2, that'll give us the negative 6x. And then when we put the plus 1 here, I'm sorry, no. What did I do wrong? What's that going to give us?
What did I give you?
What's that? That's negative 1, right?
Yeah.
And that's...
negative 6x.
So what sum is that?
That's 7.
Yeah, we need negative 5, right? So I'm
Yeah.
thinking, all right, let's switch it. Let's make it minus 2 here and minus 1 here. Now what happens? That's negative 2. And what's this one?
Negative 3x.
And now it gives us the negative 5, right?
Yeah.
All right, so here's our correct factorization. So now all we have to do is make each one of these equal to 0. So 3x minus 2 equals 0, or x minus 1 equals 0. Add 2 to both sides. 3x equals 2. Divide by 3. X equals 2/3. And for the other one, just add 1 to both sides, and we get x equals 1. So here are our two solutions for that quadratic equation. And remember, when they ask us to, or if we want to just check ourselves, what can we do to check these answers, Desiree?
You put in 2/3 for x.
Yeah, you'd go back, substitute 2/3, and actually it's best to use the original equation. So replace x with 2/3 and make sure it makes this equation true, and then also replace x with 1 and also make sure it makes that equation true. And that's a way that you can check to make sure your answers look correct. On 16. Again, we want to make it equal to 0, so hopefully you would agree to add 50x to both sides.
Yes.
So that leaves us with 7x squared. There's no x over here, so that's just going to leave us with plus 50x on this side. And then add 8 to the other side. What does that leave us with, Desiree?
That leaves us. Wouldn't that leave us with 7 because there's 1 on the other side?
Good, there's a minus 1 on the other side. Yeah, so now you have your equation equal to 0. That means we need to think about now factoring this. Are there any GCFs?
5. No.
No, I wish there were, but there aren't. So we're stuck with using those numbers. But I think it should not be a problem. What's the only way to get 7x squared?
7x and x.
Yeah, so we don't have to worry about any other possibilities. Now, what's the only way to get 7?
1 and 7.
And since our middle term is positive, and since this is positive, we know they both have to be plus. And actually, this is not too complicated. I can either put the 7 here or here.
Put it there.
This one, yeah, because this now is going to give us 7 times 7 for the 49, and then when we put the 1 there, it gives us the 1. That'll give us then a sum of 50x. Now, just make each one equal to 0. So 7x plus 1 is 0, or x plus 7 is 0. Subtract 1 from both sides, divide by 7, we get negative 1/7, and over here, just subtract 7 from both sides, we get x equals negative 7. So certain parts of that might have looked a little tricky with these weird numbers, but actually it went together to be pretty simple. And then 17 is your last one, right?
Yeah.
Alright, so on 17, get the x's by themselves. Yeah, move the x's over. We don't have any more x squared, so it's going to be 8x squared. Subtract 2x. Do you agree with minus 6x?
Mm-hmm.
And then there's nothing over here to combine with the minus 9, so that just leaves us with minus 9. And now we're equal to 0. Any GCF?
No.
Unfortunately, no. So, let's then see if we can break this up into two binomials. Fatima, if you already got this, let us try one or two possibilities, and then I want you to tell us what it is. What could we do to get the 8x squared, Wilson or Fatima?
8x squared, let's do, you know, 4x times 2x.
Yeah, we could try 4x and 2x. That's a possibility. What do we know about what the two signs have to be, knowing that this is negative right here?
The other has to be positive.
Yeah, one's going to have to be plus, and one's going to have to be minus, and now we need to think about factors of negative 9.
3 and 3.
3 and 3? Alright, so let's try plus 3 and minus 3. You guys made this too easy, didn't you? Alright, so what are we going to have here?
We have 5x.
That's
No,
a 3.
6x.
That's a very bad 3. Yeah, that's going to give you 6x, and what's this going to give you?
Negative 12x.
Negative 12. So does the negative 12 and the plus 6 give you the minus 6?
Yes.
Yeah. You guys made it easy. I would have been trying like 2 or 3 different times. Alright, but you understand on this one, you might have tried several different ones before you found the right one, and that's okay. Alright, but you got it right on the first one.
We got
So,
very lucky.
say it, Wilson?
We got very lucky.
We did. Or maybe it's
Yeah,
just
but
the...
mine's a perfect square, so I probably would have used 3 and 3 anyway.
Okay. Yeah, that makes sense to try it. But 8 is not a perfect square, so that's definitely not a perfect square trinomial. But yeah, whatever you're thinking, try it. And the more you try these, the faster you're going to be able to figure them out. So now all you do is make each one equal to 0. Subtract 3 from both sides and you get 4x equals negative 3. Divide by 4 and you get x equals negative 3/4. And then on the other side, add 3 to both sides. And then divide by 2. Do you agree with that, Fatima? Yeah? Alright, so it looks like we got these.